Hello, my name is Abdukrim Abdi, and this is a way to solve thermal heat waste with nanotech. The reason for this is that as the world gets hotter because of CO2 levels, a way to solve this is with something that nuclear power plants waste a lot of, and other types of things waste a lot of, which is heat. Heat is something that we don't take advantage of, which we should. Just like the 1800s, steam was everything. I think that as we keep going, heat could be, and it could solve two issues at once. The project is a theoretical nano concept that could solve heat waste in large quantities. The thermoacoustic power generation technology, which is considered a way to recover, for example, industrial heat, solar thermal, geothermal, and it's a real solution to these big problem. It takes something brand new and combines it with something that has existed for over a century. It is very hard to explain with everything that goes on. So I'll go by one and explain the physics of every one of them, and then finally show you the finished product. The main one is the Stirling engine, which is one of physics main, which uses one of physics main heat properties, which is that heat flows up. By using this property in a simple but ingenious way, it can make a piston move up, which is really important. And then there's the harder aspects to explain, which is the triboelectric nano generator, also called the TENG. It's something that generates electricity from movement. It's usually used in waves and stuff like that, so that when a wave hits it, it creates movement. It creates electricity from just a wave. Then it goes back up, and the next wave hits, and it keeps doing it. But it could also be used in something like this. We need this because the mechanical energy that we used in heat recovery systems is only utilized to rotate the turbine for the electromagnetic generator, also called the EMG. And this dissipates if the mechanical energy before the mechanical energy is harvested. So the performance of a single EMG can be greatly increased by adding a TENG. The way to add a TNG is very easy, but to make it so that the TNG and the EMG work together amazing and perfectly is how the Stirling engine comes in. The physics of the Stirling engine is very interesting. It has a sealed cylinder inside it with one side hot and one side cold, and the whole what is it called, displacer is something sealed with one part, what is it called, working gas. It can be air, helium, or hydrogen, anything like that. But as the mechanism from one side gets hotter, it goes up and moves the cylinder up, which pushes a piston up, and then something called a heat sink will absorb all the heat and put in a heat regenerator, and then the cylinder will go back down. I'll explain this more thoroughly as we go on. The physics that we learned that could be described with this, what's happening, is the conservation of energy. It uses a special one called the thermodynamics, first law of thermodynamics. Um, the law being energy's transfer is associated with mass crossing the control boundary, external work or heat transfer across the boundary, also called the first law of thermodynamics. It takes advantage of this by doing exactly what it says. It uses the change of temperature to move a cylinder, which pushes a piston. And as long as that entropy, which is something else that I'll explain, is not even, it will be able to keep moving. The equation for the first law of thermodynamics is the change in internal energy equals the heat added to the system minus the work done by the system. So you're seeing perfectly how this equation is used for this thing. This sums up everything that could be used in an engine. So all engines use the first law of thermodynamics in a simple way, but this one uses it to the bottom, like floor. And as you looked at this, you might have caught on that why if the cylinder releases the heat, since entropy, which is the second law of thermodynamics, saying that the thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical energy will eventually take place, meaning that eventually the heat added to the system will be the same as the change to the internal system, so no work will be done. This won't happen because the cold side, which I mentioned before, is something that I just said, the heat sink. So the heat sink will cool down because it has something called a radiator, which is a piece of fin, a metal fin attached. As the hot gas moves past the regenerator, and the regenerator is something that when it goes up, it gives it to all the heat that it just pushed up. As it gives it this, the regenerator holds on to some of the heat. When the gases move back down, it picks up the heat again without the regenerator. This heat would be lost to the atmosphere if it didn't do this. So you don't want all the heat lost at the first time the piston pushes it up, because right when the cylinder goes up and comes back down, if you have no more heat for you to push back up, then it's eventually going to reach entropy in like the third to fourth motion. You want to keep this motion going on for as long as possible so that you get the maximum amount of electricity from it. The combination of this three things will be the Stirling engine will move up and down because of heat, and the TNG will use this to create electricity. The theoretical papers that I listed before all make it so that it's in small quantities. So they're making the TENG very small. They're making what is it called, EMG, very small. As you can see here, the displacer piston isn't even large enough to be an actual Stirling engine, and that's the problem. If you were able to put this into something like nuclear energy, I think it should be very big. There isn't a limit to the size of how big these things can be. So the bigger they are, the more energy they could absorb at once. And if the heat can change it and push the piston up, it'll create more energy at once, better than it could at holding it. And the heat sink and the regenerator won't have to hold in as much heat. You probably won't even need them. The difficulties and conclusion with this is that this hasn't really been tested. Changing the size brings in its own difficulties that have not been shown. So it might make it so that there's new problems that we haven't faced before. Also, the biggest problem is the TENG disk, which is you have to replace every time because electricity can't just keep flowing in, and the heat will eventually be not it won't be able to keep up with the heat. So if it gets too hot or the piston moves too fast, the EMG will convert more electricity than the TNG can. So the TENG was just created a few years ago. It is not able to keep up with something as old as a Stirling engine or keep up with how high level EMG is. That doesn't mean that this idea should be given up on. This idea is a really good way to fix something that's been a problem and will continue to be a problem. And that's my sources. Thank you. Yes.